This lesson will combine everything that we've covered in Chapter 3 with everything that we've covered this chapter to bring you the concept of a dynamically named range. So now, remember what named ranges do? They assign a specific name to a range. And then what do our dynamic reference formulas do? Well, they calculate a range reference from some inputs. So then, a dynamic named range is a named range that dynamically calculates the range that it will refer to. In other words, they're pretty awesome. So how can we create a dynamic named range? We create dynamic named ranges just like any other named range, except we use one of our reference formulas. I'll start by typing B3 into cell A1, and I'll show you why shortly. I'm going to define a new name, and I'm going to call it z_my_indirect_test. And within my refers to field, rather than pointing to a range, I'm going to use an indirect function. Within my indirect function, I'll have it point to cell A1, which in this case will end up pointing to B3. As you can see, I do have some values from A3 through D5. In cell B1, I'll set the value here equal to a formula. I'll use z_my_indirect_test. And before I press enter, you can see that it looks like it's referring to cell A1 since cell A1 is highlighted. This can be fairly misleading, which is one of the weaknesses of dynamically named ranges. However, it's also useful to know that this is where the name gets its information from. Once I do press enter, the value I get is that from cell B3. We've just wrapped our indirect function into our named range. For this example, that's pretty useless. So let's go over to our exercise 3 solution and see what we can do there. It's always nice to have a reason for creating a dynamically named range. Do you remember how we created the type of sale and used the indirect local cost of goods to make it work? Well, honestly, I don't like seeing the indirect in my function here because it makes our formula harder to read and understand. So what if we made the local cost of goods a dynamic name? I can go into my name manager, find local cost of goods, and edit it. All I have to do is wrap my reference with indirect, press OK, and now I have a dynamic named range to use for my cost of goods. Of course, now I need to modify my formula to remove the indirect. But once it's been removed, since the indirect is directly incorporated into my named range, my formula goes back to working. There are both pros and cons to this approach. Of benefit, the local cost of goods name now better represents what the name means. It points to the cost of goods for the local worksheet definition rather than to a cell that contains a string telling you which name to be used. Additionally, for supporting users who might be unfamiliar with the indirect function, you've now created a name that they can use that takes advantage of that function without needing to know how to use it at all. On the downside, since the indirect function is effectively hidden, users could implement it in many places without ever realizing that they are doing so. The name now has to calculate, and any cells that rely on the name and cells downstream of those cells will also have to recalculate. This is a nice simple example of the indirect function's use as a dynamic named range. So let's go look at how we can apply the offset function to create a dynamically named range with our previous baseball example. Before we go too far with the offset, I'm going to introduce another concept that we just implemented without really discussing. A named range can actually use another named range as a reference. It doesn't have to point to a specific group of cells or a function operating on a specific group of cells. This can be particularly useful for dynamic named ranges that use offset, so let's build a few supporting pieces first. So the static named ranges I'm going to create will point to our start year, our end year, the maximum range of our plate appearances, and our team wins. I'm going to create 2 additional named ranges that are simply going to point to the first cell in each of the data columns. I'm going to call these the start positions. Each of these named ranges represents some piece of the puzzle for determining what our total target analysis area consists of. In addition to these, I'm going to create 2 more local named ranges. One for analyzing plate appearances, and one for analyzing the win totals. For each of these, I'm going to set them to the maximum named range for the same type. I can go to my linest function and replace my current offset function with each of these names, and have a working estimate for Bonds and A-Rod. But again, since Pudge does not have 22 data points, he errors out. These named ranges currently follow a 3-step process. First, they start at and evaluate the local name. Since this evaluates to the maximum name then gets evaluated, and the result is a static range, so that range is what finally gets put through. In essence, our local name is already a dynamically named range. We can make changes to the maximum name, and our analysis name will update to reflect those new changes. However, we're going to turn our local name into an offset function that uses only other named ranges. Sounds a little crazy, doesn't it? Well, let's go seriously overboard. We're going to use dynamic names within a dynamic name. We'll do this to actually simplify our problem somewhat and break it into multiple steps. Don't worry too heavily about these functions as we go. You'll be able to dive into the file and look at the named ranges and formulas yourself after the video. There are quite a few, so I'm going to go quite quickly. The first names that I'll edit will be the analysis start names. For each of these, we're going to set them to offset functions that use the match function to determine where to start at. These functions are simply going to calculate how many cells down to move using the match function, so that if my index happens to change from values like 1, 2, and 3 to actual years, the named ranges would still work. Each of these dynamically named ranges can now function as an input for my local named ranges, so that within each local range, we only have to calculate the height and the width. So let's take a look at our local plate appearances range and think about how we want to do this. First, I'm going to start with just our offset function, and the offset function is going to start at the Z plate appearances start position. Since this reference is already an offset that moves down the appropriate number of rows, I do not need to move down any more rows or any more columns. For our height, we're going to want to use the count function of our maximum appearances name, but we also need to figure out how to subtract the distance that we've moved down. Take a moment to think about how we could do that, and before we adjust for that, I'm going to go ahead and add the minimum component to figure out whether we use the ending year or the count value. For our height, we could link to our start year and subtract 1, but again, there's the future change problem. Instead, what if we used our row function? The row function returns the row of the cells in a reference, so row of our start cell will always give us a row that is greater than or equal to the smallest row of our maximum range. So all we need to do now is subtract the row start from the top row of the maximum data set. Finally, our width is still just 1, so now our name is complete. This named range is very dense, and the name for the wins data is pretty close to identical. Since it's so dense, I'm going to go through this whole process one more time with a slightly different approach. First, I'm going to go to my local team wins and I'm going to edit it to start with the offset function. And again, it's going to point to the starting position. Since the start name is an offset function that has already moved down the requisite number of rows, I'm going to use 0, 0 to indicate that we don't need to move down any further. Now, where this formula gets challenging is in our height component. The height needs to start as either the minimum number of data points available or the selected last year. We can determine how far into our data points the starting position is by taking the row of our start position and subtracting the smallest row of our maximum possible data set. Visualize this process. We have our maximum possible data set, and there's some subset of data within this set where we have selected a maximum point. We want our data set to end at the very first point that it encounters, either the maximum specified point or the point where the data physically ends. Now, as the starting point of this data set shifts down, the row of our starting position therefore increases, while the row of our maximum data sets remains unchanged. Because of this, we need to decrease our specified height by 1 for each change in that difference. That's what this function is achieving. And of course, we have to include our width of 1 to complete the name. Now I can look at my linest function and it reads very nicely. Hidden within the simple names are the complexities of determining our dataset's size. I can change my start year, I can change my end year, and I can watch my data calculations update live. This is a very complex example where I've taken you very significantly into the details of dynamic named ranges to show you what they're capable of. We'll now close this lesson out by introducing you to exercise 4. This exercise will be a fairly straightforward crunching of information. I've devised 3 different scenarios requiring a different usage of either dynamic formulas or dynamic named ranges. Each scenario consists of a step-by-step process of building a formula while also requiring some puzzle piece thinking about how to meet the solution based upon the available options. You can determine whether your solution is correct by typing the final formula into the indicated cell and putting a single quotation apostrophe in front of it, like this. Now, obviously my formula is wrong, since it has nothing to do with the question, but that cell will turn green if you input the correct formula. Good luck with the exercise. I'm sure you can handle it, and join me back here for our next lesson where we'll discuss some best practice uses of these formulas.